Hello and welcome to today's lesson where we're going to be looking at the concept of reflection, which is found in GCSE Separate Science Physics in the waves topic. So in today's lesson what we're going to be doing is we're going to try to understand the laws of reflection. So if we're successful and we learn in today's lesson, we should be able to detail the process of reflection, understand the difference between specular and diffuse reflection, and experimentally prove the law of reflection and analyse data, which falls into the following part of the AQA Separate Science Physics specification 4.6.1.3 reflection of waves, which is a separate science of physics only, required practical and concept. So in this lesson we're going to investigate the effect waves have when they hit the surface of a material. So if you consider when a wave, like a beam of light, hits the material like a glass cube, well, the visible light can either refract, reflect, or can be absorbed. Now, to refract is an example of transmission. Now, today's lesson we're only going to look at one particular effect, and that is the reflection of light. Now, if an object produces a reflection, the angle of reflection is the same as the angle of incidence, and we call this idea specular reflection, and it's said that the object is obeying the laws of reflection. So to produce specular reflection, a smooth bare surface is required, and this is found in materials like glass. Now, in specular reflection, the reflection happens in one single direction at the same angle in which the incoming ray hit the surface. Now, the image produced in specular reflection is what we call a virtual image. Now, this is an image formed where the light rays do not actually cross in space, or it's an image which cannot be formed on a screen if it was placed at the position of the image. Now, the equivalent of the specular reflection for a sound wave is an echo, so it's a very important idea, whilst diffuse reflection is when an object does not obey the laws of reflection when it reflects light waves off it. Now, to produce diffuse reflection, a rough surface is required. This is because the different orientations of the surface produce reflections at different angles. Now, we say in diffuse reflection, the reflected rays are scattered in all directions. So you've got contrasting ideas of diffuse reflection and specular reflection. Now, diffuse reflection is much more common than specular reflection, as more objects are rough than as opposed to smooth. Now, it's important to note that diffuse reflection causes light to scatter in all directions off a surface when it reflects, yet specular reflection only has reflection occurring in one direction. So reflection is when a wave interacts with material and returns in the opposite direction it originally moved in. If an object produces a reflection as an image, it obeys the laws of reflection and carries out specular reflection. Now, we can document this with something called a ray diagram, and this shows how a wave changes with the material. But in addition to a ray diagram, you can also represent this with a wavefront diagram, which shows how a wave changes with a medium. Now, the wavefront diagram shows the waves as a series of peaks or wavefronts. Now, the wavefronts have the same separation before and after reflection, as the wavelength of a wave is not changed in reflection. So the speed of a wave is not changed in reflection, and the frequency is not changed in the reflection. Now, to draw a ray diagram correctly, the diagram should be drawn with a sharp pencil, the wave path should be drawn with a ruler as a straight line, and you should always draw arrows to show the direction of the wave. So in this particular ray diagram, we have our incident ray hitting off the mirror and producing a reflected ray. Now, to help us work out the angles at which this occurs at, we draw something in called a normal. Now, the normal is an imaginary line used to refer to angles. Now, imaginary lines on ray diagrams are shown with a dashed line. Now, an imaginary line in a wave diagram means there's no physical line or presence in the real world. It's purely there to help us work out angles. So the normal is always drawn as a dashed line, as it's imaginary. Another way you could phrase it is that the normal is a construction line, as it helps us measure or construct angles in the diagram. Now, the normal is named as the normal because it is normal or perpendicular to the surface of the mirror. Now, the normal, like we said before, does not exist in reality. Now, what happens in specular reflection is the incoming ray forms an angle of incidence with the normal. Now, an arrow on the wave indicates the direction of wave motion, and then the reflected ray forms the angle of reflection with the normal, and so the arrow again is indicating the direction of the wave motion. Now, it's important to note that the angle must be from the normal to the ray. If it's from the ray to the surface as shown in the diagram, that is not the angle of incidence, it is not the angle of reflection. Now remember, the angles in ray diagrams are always formed between the ray and the normal. Now for specular reflection, the angle of incidence equals the angle of reflection. Well, that is the law of reflection. Now the law of reflection is only obeyed if the angles of incidence and refraction are found in the same plane. So it's actually important to say that for specular reflection, the angle of incidence equals the angle of reflection, and this is the law of reflection when the angles are in the same plane. Now, like we mentioned before, we have our wave diagrams following these particular rules, but obviously this is only for specular reflection. If an object does not produce a diagram where the angle of incidence is equal to the angle of reflection, we call that diffuse reflection, which is reflection off a rough surface. And a rough surface can cause the light or the wave to scatter in all directions off the surface. So we've got to look at this in the concept of a practical. Now in this practical, you're looking to find the relationship between the angle of reflection and the angle of incidence for a wave hitting the medium and work out whether it's carrying out specular reflection or it's carrying out diffuse reflection. So in this investigation, you would need a pencil, a power pack, a protractor, a ruler, a reflection drawing grid, a light ray box and a plane mirror. So what you'd do is you'd orientate your mirror so that's in the centre of a 10-degree segment or any piece of paper on a drawing grid. You draw a straight line with the pencil across the plane of the mirror on the sheet. On the centre of this line, draw a dashed line perpendicular to the original line, and we label this the normal. Then we use a protractor to draw a line entering the mirror at 10 degrees. To do this, you should mark an X on the sheet at which this is found with the protractor, and then a rule a straight line towards the mirror and label that the incident ray. You set a power pack to 12 volts, connect a ray box with a slit to the power pack, then align a ray box so the light is moving along the line of the incident ray. You then draw a straight line along the reflected ray and label this the reflected ray. You remove the ray box, light and mirror, draw in the angle of reflection and measure this with a protractor and repeat it for different values of angles of incidence as shown. So you would get a power pack, you set it to 12 volts. You would get a ray box and attach it to the power pack and place a single slit on the ray box so only one ray of light is going to be considered in this investigation. You would retrieve a plane mirror and place it in a holder as such. You place the mirror in the centre of a segment where you're going to work. Now just remember that the holder is used to secure the mirror in position so it doesn't move throughout the investigation. You would then draw in a pencil line down the plane of the mirror and then draw in a dashed line which is the normal with your pencil. Now the normal should be drawn as a dashed line down the middle of the mirror as shown. You would then place the protractor on the normal line and measure out 10 degrees. You place a marker on the 10 degrees mark with a pencil. Now remember the angle is the difference between the angle of the ray and the normal. So therefore you then use a ruler to draw in your incident ray and ensure you have your arrow in this particular diagram. So you then label it as 10 degrees. At this point you would then align the ray box down the line drawn as shown here. Now you would then place the mirror back on the plane line and observe the reflected ray. Now the darker the room, the easier it is to observe the light ray. Now you would then mark the reflected line with crosses, and the 3 crosses should be sufficient to draw a clear straight line as shown here. So use a ruler for this. It must be straight lines because the wave travels in a straight line. And then remember the angle is then measured with the protractor from the normal to the line, and then the protractor has a resolution of 1 degree. So this means the results cannot be recorded with decimal places because you have to have your resolution of your measuring device showing you how many decimal places you can record results to. Then you'd write in the reflected angle on your drawing grid and repeat it for different angles found on the worksheet. So for example, you could have 10 degrees, 20, 30, 40, 50, 60, 70 and 80. You would then draw a graph of the experimental results with the angle of reflection on the y-axis and the angle of incidence on the x-axis, and you then draw in a line of best fit. So what have we learned in today's lesson? A wave can be reflected at the boundary between 2 different materials. Waves can be absorbed or transmitted at the boundary between 2 materials. You should be able to construct ray diagrams to illustrate the effect of reflection of a wave at a surface, and you should be able to describe the effects of reflection, transmission and absorption of waves at material interfaces. The reflection from a smooth surface in a single direction is called specular reflection. Reflection from a rough surface causes scattering. This is called diffuse reflection. So if we've been successful and we've learnt in today's lesson, we should be able to detail the process of reflection, understand the difference between specular reflection and diffuse reflection, and then finally experimentally prove the law of reflection and analyse experimental data. I hope you've enjoyed today's lesson where we've looked at reflection, which is part of the GCSE Separate Science topic in physics in waves. Thank you very much for listening and have a lovely day.